Welcome, everyone. Thank you for attending this webinar. We do appreciate your interest in this particular topic. Thank you for your punctuality to let us start in time this meeting. For those who don't know INECO, we are a Spanish consultancy firm, shared by public companies, ENAIRE, the main Spanish air navigation service provider, ADIF, the railway infrastructure manager, and Renfe, the main railway operator. We develop our activities in the 5 continents. My name is Daniel, and my role is to conduct this webinar. I have an issue with the presentation. Just a minute. Okay, thank you. I invite you to include human performance into your company activities. We have already done. So, as Kalesi said, you only have 2 options. Do you accept our challenge? Is human performance considered as a key point in your safety assessment? How human performance is taken into account into your organization? Today, we want to show you INECO point of view in terms of human performance influence in several modes of transport. We have 4 different approaches to this point. One's coming from the operational side, and the others as a part of a decision making for future development. Through these panels, I hope we can provide our point of view. But before we start, let me mention some basic rules regarding today's session. Your microphones should be mute. Cameras must be disconnected except for the speaker. Your questions, comments, doubts should be written on the chat channel. Our panels will be developed for 4 INECO experts. At the end of every panel, there will be a question round. And at the end of the session, there will be another round to answer your questions. But if some questions remain without an answer, we will send you in the following days via email. It is commonly accepted that human factor is a leading aspect in the 80% of the accidents. Traditionally, operational safety has considered human intervention as the weakest point of the system. And the general recommendation is training. We need to consider human performance as a key element in transport industry. For instance, fatigue, stress, inappropriate workload, routinely tasks, or lacks of training could lead into safety incidents, not as an error, just human issues. We have to change our perspective to a human-centric approach as the solution of systems inefficiencies. As a result of this point of view, INECO has developed a global approach methodology to analyze human contribution to operational safety. In INECO, we try to identify synergies between the different means of transport to provide solutions to all our customers. As a result of this vision, a research and innovation process was launched to merge human aspect in ATN and railway operational safety. This methodology was presented to the annual Council Safety Achievement Award in 2019. In our first panel, we want to show you a brief sum up of this methodology. As we know, the evolution of human factor in the different sectors of the industry has not the same maturity level in the way they are considered, in the way how risk analysis are performed, or in the requirements that have to be implemented. Moreover, we need to look forward and bring into our studies examples for other industries and incorporate human factors in future development decision-making processes. We have to take advantage of data science techniques to be used to enhance the knowledge that we have of human performance and take the lesson learned into our studies in consideration into our industry. We hope this webinar fulfills your expectations and keep your attention in the solutions that INECO can provide to your organizations. But before our first panel, we want to show you a brief animation of our creative process. Before or after this animation, we will launch a small poll. Please prepare your mobile phones to read, to check the QR code to answer the poll.
At INECO, innovation helps us to be better every day. Committed to ideas that contribute to safer, more sustainable and connected mobility. Integration of the human factor in risk analysis. Safer transport. About 80% of transport accidents are due to the human factor. And what if risk analysis and safety assessments took into account human errors? Consider the impact of the human factor as a fundamental part of any phase of a system's life cycle. The final innovation product provides a methodology for integrating the human factor into conventional risk analysis. By defining a taxonomy of human error and a criterion for accepting criticality, the factors that induce the staff involved to error have been determined. Only by knowing where and why the system fails will we be able to forecast human error and apply solutions that prevent it. INECO has been awarded the CANSO Global Safety Achievement Award 2019. Thanks to the success of this innovative project, Human Factor.
Now, in a few seconds, you will see the question in your screen. But before, to help our experts to develop this webinar, please answer the following question. What approach do you think is the most effective at identifying and managing human factors into safety assessments? We propose you 3 options: failure approach, a success approach, or both. What do you think? We give you a couple of minutes to answer this simple question or not? I don't know if we have some results. I'm trying to find the solution of the poll. Okay, so most of you think that the solution is both. More than half of the participants in this webinar think that both is the right answer. I don't know. Probably our expert will give you some clues to identify what is the right solution. Okay, I don't know if everybody has answered. Okay, let's go. Our first panel is going to be presented by Marisol de Mena. Marisol de Mena is an aeronautical psychologist. She's certified by the European Aviation for Aviation Psychology. She's an expert in safety and human factors. In the last 15 years, she's been working for large aircraft manufacturers, Airbus and Boeing, airliners, and small flight schools, implementing the SMS and assessing in human performance in flight simulators. She has been working as ICAO officer in the State Safety Program in the South America region. She's going to present a brief introduction of the INECO methodologies to integrate human performance into safety assessments. Marisol, please, go ahead.
Thank you, Daniel. Hello, everyone. Along all these years working for integrating human factors into aviation, I live the pressures of the people involved in the operations. Pressures like maintenance, that have maintenance staff working on new technology, of the fatigue problems of sick workers, the effects of stress in health and well-being imposed by certain operational conditions. These pressures are essential to safety because every operation is steeped in human factors. That's why a good management of the people issues takes a central role in the strategic plan of the company. The railway and the aviation safety areas, we've got a lot in common. We share principles and safety concepts. And specifically in the development of this technology, this methodology, we work together creating synergies to enrich the procedure of both sectors with a shared goal to create a method valid for railway and aircraft operators that will be suitable for any other sector. In INECO, we are aware that not all organizations have the same resources and maturity to address these human factors studies because these solutions need a deep understanding on the scientific principles and apply experience, and then how to fit it in safety risk assessments. So generally, they propose two generic recommendations about human factors instead of specific measures. Furthermore, national and international regulations are demanding to take human factors into account. So this methodology has never been more important. Well, what is human factors? Human factors is a discipline that aims to understand and manage through scientific theories human capabilities and limitations for the safe and efficient performance of the services offered by the organization. After performing an exhaustive benchmarking, we identify different human factors, methods, and techniques matching with safety. Some approaches are more focused on human performance and some others on human limitations. Some traditional safety assessments are focused on a failure approach, identifying threats and mitigating possible risks. Aligned with this approach, the human reliability assessment is an integral part of a safety assessment that aims to understand the why behind the human error. and reduce the human component to risk. Another traditional assessment, like success approach, analyzed those situations where human performance was outstanding. Do you remember, for instance, the flight 1549, also called the Miracle on the River Hudson? Well, the crew only had 3 minutes since the moment the flight crew identified a massive engine failure until the moment the Captain Sally executed or performed an emergency landing. Only 3 minutes. The crew performance was amazing. These kind of events and the actor's performance are worthy of being studied, apart from accidents, I think. So these approaches are represented in these details of this normal distribution. Specifically, the analysis of the events more related to safety are presented in the left tail of the distribution, and the ones more related to human capabilities on the left on the distribution. But please have a look on the middle. If you see the events represented in here are showing us that most of daily operations are safe. A more contemporary approach focuses exactly on the events represented here. These options complements the other two. It observes the normal operations and extracts trends and behavioral patterns. Do you remember the pool that Daniel mentioned a minute ago? Well, in INECO, we think that these 3 approaches can be handled together. We can study the failures, we can study the success and the normal operations. Currently, both in railway and in aviation sectors, we have large amount of data stored. And generally, this data is ignored or unknown. But thanks today, and thanks to the science data and artificial intelligence, we can address this interesting approach. Well, let's see the process. How do we integrate human factors in risk analysis? As you will see in this slide, the diagram, the blue diagram corresponds to the stages covered by the safety assessment, and the purple, the phases that our methodology aimed to cover. Both of them perform a phase process where different activities are to be developed, and we design different templates, and they are available for you to deal with the objectives of each stage. Both start with the description of the system, scoping the system analysis as a set composed of factors with their roles and their interfaces with equipment, procedures, environment, organization, and other people within the organization, of course. And then the methodology focuses on the task analysis. While during the functional hazard assessment, potential failure modes are identified and the risks are assessed, parallelly in the methodology, we identify the human factors issues. Different methods can be used to collect and represent the performance-related information for its task. Available generic task analysis can save time and harmonize the process. Human issues when performing tasks are identified, and the analysis are held to align them with hazards. Words, human performance within the task is assessed. Within the functional hazard assessment, the hazards are expressed in terms of severity. Meanwhile, for the human factors assessment, the human performance issues are selected and prioritized. Several techniques are used, such as brainstorming session, or interview or structured interviews or surveys. The main objective is consider experts or users' knowledge and judgment about how easy it is to make mistakes when performing certain tasks. And then all of us, we classify together this task based on 5 parameters you have in here in the diagram. According to frequency, how often this task is performed, or the execution time, the time available to perform it, as well as the task complexity, location, and whether it is performed in different seats, for instance. Then the performance shaping factors, as well as its affections degree, are identified. Performance shaping factors are those conditioning factors that can negatively affect human performance in each subtask. Factors as mental workload while performing high demanding tasks. The list of possible factors affecting deviations can be done with taxonomy that incorporate neutral languages without any judgment value. And a cross-checks needs to be done with safety assessments, and we can provide them with more hazard related to tasks that might not be taken into account previously. Once in the hazards and the human issues have been prioritized in the previous stage according to threats, criticality, and the level of influence of the occurrence of the failure, mitigation measures that meet that priority are set. So those which level of conditions are more critical for the case will be the ones that should be devoted more time and resources and to be stricter when monitoring. At this stage, INECO developed a technique called FARA, Feasible Actions Rules for Human Reliability Assessment. It was based on a technique of the nuclear sector called NARA, which allows a high level of breakdown around main groups of mitigating measures. FARA complies with the elements defined in CANSO Human Performance Standards of Excellence to achieve an effective integration and management of the human factors within the organizations since a systemic point of view. So, to sum it up, this methodology proposes a practical process to systematically identify and manage human factors from transport projects. It is comprehensive and transversal to safety studies. It allows to understand the human behavioral patterns when actually working on the system by identifying everyday performance adjustments when work as done differs from work as imagined. And then as we incorporate all the decisions, all the subject matter experts' judgments about latent conditions, we can provide decision makers with specific recommendations. And as apply, and it can be applied at any phase of the project life cycle. So I will leave you with my colleagues and they are going to present you more cases, more oriented to these applications. So thank you very much for your attention and your time. It will be my pleasure to be in contact if you have any questions.
Thank you, Marisol, for this clear explanation on how INECO consider this topic. And I think that the answer to the poll should be both cases. We have just one or two questions in our chat. I invite you to participate, but I'm going to ask you what people attending want to know. How to measure things that are difficult to assess, to measure, to check into normal operations, but go right.
Check normal things in difficult things. I think it's a very practical question. Well, as a safety specialist, when I need to identify those kind of events, sometimes the solution is not so evident. And what I recommend is to focus on those events that occur many times, and their consequences probably are not so severe. Probably we have low consequences. Probably we don't have any accident, but these events are occurring many times. So I will focus on that kind of events. For instance, if we are monitoring normal flight operations, for instance, what I will do is to, for instance, to select a flight phase, a landing phase, and I will focus on those events more critical, for instance, an unstabilized approach. And of course, this could be this will happen because of the meteorological conditions or low visibility, but these factors are not so common. But we need to identify why pilots are performing these small adjustments to adapt these changing situations. For me, these human factors are very important, and we can extract a lot of information about this normal situation.
Thank you for your answer. I think there's another question, but probably we will answer then at the end of the panel.
Mm-hmm.
Okay. Our next expert is Tatiana Rueda. Tatiana has a bachelor in physics science and advanced studies in chemical physics, as well as a master in railway system. She has more than 15 years of experience in the field of runway safety and reliability, availability, and maintainability assessment in railway systems. She has been working for NECO for the last 7 years, where she's acting as an independent safety analyst. She has been the project manager of the development of the methodology that Marisol has presented us a few minutes ago. And Tatiana is going to show us how to develop, how to apply in a practical case this methodology. So Tatiana, show us how to proceed.
Thank you, Daniel, for your presentation. Now, I am going to talk about the application of the methodology in one railway case. In the railway environment, when an accident occurs, we are very used to hear things like, it was the driver error, or it was caused by the human error. But these are statements very curious for me. First of all, because we normally focus on the human error when an accident occurs, but in rare occasions, we heard the success histories in which the human prevents from a tragedy. I think that maybe we are predisposed the public opinion. It's like, for example, you want to buy a purple car because it's very original, and suddenly you only see purple cars on the road. Don't you think that maybe we are predisposed to the public opinion to see only the purple cars instead the wide range of colors? On the other hand, it catches my attention that when an accident occurs, we say that most accidents are related to the human factor. But when we do the safety analysis, we normally put in the center the equipment and the systems. But don't you think that maybe this is a contradictory idea? In INECO, we want to put the human on the center, and we have started applying the methodology in some railway cases. Let me present now a couple of friends of mine. This is Mary. She's a very self-confident and intelligent person. She loves her job and has been developing it for more than 10 years. She is the traffic responsible of one station in a conventional Spanish railway line. And this is Paul. He has a very positive character and is a very hard worker. He also has a great experience of about 15 years, but he gets a little nervous when his station starts to be overcrowded. He is the traffic responsible of a station that is next to the Mary station. Both Mary and Paul's station are operated by a telephone blocking. Let me explain a little more detail about this kind of operation between two stations. When Paul wants to dispatch a train to Mary station, he asks for the permission to Mary that check that the previous train has arrived at her station in full condition, and then give the permission to Paul. Then Paul put the output signal into the green and give the permission to the train to start its movement. This table shows an extract of the task analysis performed for this case study. But we are going to focus only on these 3 tasks. Let me explain a little more details about these 3 tasks. When Paul wants to dispatch a train, and he has all the corresponding permission, he checks that all the elements under his responsibility are okay. In this case, he has the telephone message that he can dispatch the train 22457, and he puts the output signal into the green. He does that by pressing in his console. Then give the permission to the train that start its movement. When we have done the task analysis, now we need to identify which are the hazards related each of the tasks that we have identified. And this table shows the stack of the hazards that have been identified for these three tasks, with the consequences and the severity of each of the hazards. Now, we are going to see an example about a hazard that can lead to an accident. A train goes from Mary Station to Pal Station with all his corresponding permissions. A time later, a train arrives at Pau Station. And this station starts to be overcrowded. And Paul, due to a lapsus, forget that there is a train running in the opposite direction. And without having still the corresponding permission, he gives the OK to the train to start his movement and put the output signal into the green. Then the train starts its movement. When Paul realizes about the situation, he has no chance to stop the train. We have the task and we have identified the hazard, then we need to rank the task. And we can do this taking into account two factors. The first one is the difficulty of performing each of these tasks. And we can do this taking into account these 5 parameters that has been explained in the previous panel. And the second factor is the severity in case of a bad execution of each of the tasks. With this information, we can then rank the tasks. This table shows the tasks that we have analyzed and the result of the rest of them. As you can see, the first one, the most critical one, is to activate the output signal. It could be logical, but not only for the difficulty of performing the task, but above all, because of the criticality of this task. On the other hand, what condition the human behavior are not only regarding the task. In fact, there is another environmental factor that can have a strong impact on the human behavior. These factors are the performance shaping factors and can be, for example, the overconfidence, the communication protocols, the ergonomics, the fatigue, or the stress, among others. And how can we measure these factors? Okay. Next thing is to allocate for each of the tasks, we need to allocate the factor that can condition the execution of this task. For this example, these are the factors that have been allocated, and the table below shows the description of each of them. When we have this factor, then again, we need to rank it. And we can do that, again, taking into account 2 factors. The first one is the degree in which each of these factors can affect the human behavior. And the second one is the severity in case of an error. The table below shows the rank for this case study. Now, we have the task and we have ranked the task. We have identified the hazard and we have the performing safety factor. With all of this information, we can make the recommendation. And the recommendation could be both to improve the management of the factors or to impact of the way that the task needs to be executed. For this case study, we have obtained these 5 recommendations. The first one is regarding the fatigue. Is to perform an analysis of shifts and tasks to reduce the operator fatigue. The second one is regarding the interfaces. Is to create an alternative interface between the train and the station to be able to communicate in case of an emergency and in those cases where the train ground system is not available. The third one is regarding the distraction and overconfidence, is to have a kind of automation process so that the safety does not fall solely on people on this type of blocking system. Next one is regarding the conflict between safety and customer service, and is a kind of awareness campaign for operators. Finally, handover protocols is to review this kind of protocols. Let me conclude this panel with two key facts. The first one is that with this methodology, we can systematically analyze the system in order to obtain the recommendation to help people to do their job in the best possible conditions. And the second one is that for this sample example, and by analyzing only 3 tasks, we have obtained 5 recommendations. Can you imagine how many recommendations we can have if we analyze a complete system? Thank you very much for your time and your attention. I will be happy to answer your questions. Thank you.
Thank you, Tatiana. I think that after your presentation, we have a better understanding of how to conduct a safety performance assessment in a real case. We have 1 or 2 questions in our chat, but I want to know, probably we will answer all of them at the end of the session. But one of the recommendations that had been obtained, I think, in the automation of some systems, how is possible to determine with your methodology which systems should be automated?
Thank you for the question. Automation. Okay, I think this is a good one. One strength of the methodology is that we can obtain a run for the task. So we can obtain which are the best candidate tasks to be automated, because these are the most critical. But we need more information. First of all, we need to do a technical analysis about the events and benchmarking about the techniques that are available in the market to obtain which task will be automated, because not all of them can be automated. So for this first study, we need to discard some of the tasks. And with the remaining tasks, we need to do a cost-benefit analysis. So with all of this information, with the ranking of the tasks and the list of the most critical tasks, with the techniques that are in the market, and with the cost-benefit analysis, then we can have the best candidate, the tasks that are the best candidate to be automated.
Okay, thank you, Tatiana. As I mentioned before, we have some questions by the final round. Okay. So we are going to go to our next expert. We are changing from an operational perspective to a decision-making approach. Our next expert is Víctor Gordo. Víctor is a master in aeronautical engineering and business administration with more than 22 years of experience in the field of navigation system. He's specialized in navigation aids, satellite system, and surveillance systems. He has been working in Spain for AENA and ENAIRE. He has been participating in some European research projects and in several countries like Egypt, Oman, Taiwan, or Colombia. Nowadays, he's involved in some project regarding unmanned aircraft system, operation, and the US space implementation, working in some European collaborative projects like Terra, Domus, or DACUS. He has been a lecturer at the Technical University of Madrid for more than 10 years. And now he is going to present how human performance can be taken into consideration in the decision-making process to implement new system or new concept of operation. Please, Victor, the floor is yours.
Thank you very much, Daniel, for your kind introduction. And yes, well, first of all, good evening to everybody, or good morning if you are in America. And thank you very much for attending this webinar. And as Daniel has said, in this panel, we are going to talk about another potential application of this human factor methodology. In the previous panels, we have talked about the application of the methodology to existing systems, but the methodology is also very powerful in the design phase of a new system, even in the concept of operation. Well, as said, in previous panels, we have discussed how we can improve the human behavior in an existing system, considering the data gathered. But in the concept of operation or design phase of a new system, we can see how the design can be done to improve the human performance or to ease the human performance. As an example, we have chosen the air traffic controller activity in control area space, where there are also drones, both UAS or air taxis, UAM, in what we call a US space environment. Well, why have we chosen this use case? Well, we consider a very interesting case by two main features. First of all, the necessity. Well, there is an expected large growth of drone operations in the following years, but also due to the futures associated to this system, because we have a fully automated system as it is US space, working together with a system supporting human decision as it is ATM. So, well, before applying the methodology, let's check these two statements. First of all, the market forecast. Well, so attending to several sources, for example, we have here the data from Fedotop, we expect that by 2035, we will have a market of more than $200 billion between drones and UAM. And last drone delivery market with drones and air taxi are things to be profitable by 2030. So yes, we expect a large growth of the drone sector, and we should be prepared for it. And then what is US space? Well, US space is defined as a set of new services and specific procedures designed to support safe, efficient, and secure access to airspace for a large number of drones. Well, most drones operations are going to happen in what we call very low level, below 500 feet. But as the number of drones grows, there will be a large interaction between them. So we will need systems, the US space services, to avoid collisions, both in the strategic phase, flight plans, and in real-time, tactical deconflictions. They will also manage, for example, how to deal with, for example, helicopters in very low levels. But beyond that, the US space environment will overlap with the ATM environment in some cases. For example, imagine a drone flying from the airport to the city to deliver a good, or more clearly, an air taxi carrying a person to take an aircraft on the airport. So in this case, the controller space and the US space domain will be fully overlapped, and there will be a required interaction affecting the air traffic controllers. This is the use case we are going to study. And now let's apply the methodology, the human factor methodology in this case. As in the other case, the first step is always the description of the system. We have the air traffic controller within the ATM US space interface. The actors involved are for sure the air traffic controllers, but also the aircraft pilot and the drone pilot or operator. The roles, well, the air traffic controller has to monitor the surrounding traffic, main aircraft, to receive information of alerts about UAS in the area, and to assess the potential hazards, issuing corrective actions to the drone or to the aircraft when required. The US pilot will command and monitor the flight and receive and react to the corrective actions, and so do the US pilot. Regarding the interfaces, we have, in this case, a liveware hardware interface between the air traffic controller and the ATM system interfacing the US space services, but also two liveware interfaces between the air traffic controller and the US pilot, and the air traffic controllers and the aircraft pilot. And here is when we can see the difference of the application of this methodology in this case, new concept of operation, design phase. In this case, what we want to optimize is not the human behavior, is to ease the human behavior by optimizing the interface design between ATM and US space. To that end, we are going to analyze two key aspects. One is what kind of information is going to be presented to the air traffic controllers. Every drone in the surroundings, in the vicinity, or only others of drone entering in critical areas for human aviation. And also the communication in case of needing to issue corrected actions. Or the communication going to be issued by classical radio communication or through the UTM or US space interface only. Well, so let's analyze that. First of all, we have to do the human performance identification. This task consists in analyzing all the tasks associated to each person to identify the potential hazards associated to each task and to identify the potential causes. For example, the air traffic controllers, one of its tasks will be to recognize or to react to alarms due to the presence of UAS in area of movement of manned aircraft. Potential hazards, not reacting to this US alarm or detecting the alarm, but not recognizing it as hazardous. And the possible causes are closely linked to different areas of the interface, training, whatever. Once done this, we can see how the analysis of this task, the classification of this task will depend on the scenario we have chosen. We can see that we have to split the scenario in four parts, depending on the type of information presentation and the type of communication between air traffic controller and UAS operators. Then we can see, or we can classify this task with regard to 4 parameters. First of all, the frequency, how often this task is performed. It can be done based on skills, it could require rules, or in the most complex case, it could require specific knowledge. Another parameter is the complexity of the task, low, medium, or high. The location, the knowledge on the environment where the task is executed, and finally, the execution time. Very low, excessive, or just normal. With all this in hand, we have different task classification values for the same task in the different scenarios we are considering. And this is a very interesting information. And once evaluated the human error and classified the task, we can identify the criticality of the hazards associated to each task and the contribution of each task to the occurrence of the hazards. This leads to the identification of what we call performance shaping factors. This is those factors that can contribute to the occurrence of human errors in each task. And we can also identify the degree of affection. So for each task, we identify a number of performance shaping factors we have to do with communications, with the interfaces, with training, with stress. And for each task, we identify which of them affect each task in each scenario and which of them, which is the degree of affection. Then we obtain a criticality of each task in each scenario and also the criticality of the performance shaping factors in each scenario. So finally, with all this information, we can compare the scenarios. To that end, we have proposed a matrix presenting in columns the type of information presenting and in rows the type of communications. So we can see that for the different scenarios, we have different values of the criticality of the task, and even in some scenarios, tasks tend to be more critical than in other scenarios. Also, with regard to the performance shaping factors, we can see that in some scenarios, some factors or some performance shaping factors are much more critical than in others. Even that in some scenarios, the performance shaping factors tend to be greater than in others. So this information will be very useful in order to do the design of this system, taking into account which are the less stringent values of performance shaping factors and even defining the knowledge and the interfaces so as we improve this performance shaping factor, reducing the contribution to potential hazards. And well, this is all from my side. Thank you very much for your attention, and your comments and questions will be really, really welcome.
Thank you, Victor. I think this is a different approach in the definition phase, new concept of operation. a new application, the human factor case. We have some questions in our chat, but while we are collecting them, probably we will have the opportunity to answer them at the end of the session. I want to know something. What kind of recommendation do you expect to extract from applying this methodology in the case of USpace?
Well, thank you very much, Daniel. It's an interesting question. As you can see, you have seen in the presentation, we are comparing two extreme options, both in communications and in information presentation. Probably, in the reality, the solution is not the black or the white, but this is a kind of gray. So we expect that this recommendation could allow us to identify which are the most critical performance safety factors in each extreme scenario, and to identify which is the mix between the scenario that will accommodate the best human performance. That's what we expect.
Okay, thank you very much, Victor.
Thank you
it's
very
a
much.
clear explanation. I hope we can apply this methodology in the future. Our next expert is José Manuel Risque. José Manuel has a bachelor in aeronautical engineering. He has more than 25 years of experience in the ATM management domain. During this period, he has got a broad experience in modeling the dynamic systems. He has been in touch with the real operation with air traffic controllers. In addition, for the last 15 years, he has been involved in some European collaborative projects within CESAR, paying special attention to real simulation and taking into account human performance into the project, into the studies they have performed. During the last decade, he has been developing artificial intelligence and big data solutions. José Manuel is going to present us a new challenging scenario, how to take advance, how to get some information for the data that service provider can collect. José Manuel, let us know INECO's vision in this field.
Thank you, Daniel. Good morning or good afternoon, everybody. Some good news for you. I'm almost the last one. Robots, artificial intelligence, are they black boxes? Would you trust on them? In INECO, we have held a lot of sessions with experts on different domains, airports, air navigation, railways, and there is always an expert that says, I don't trust artificial intelligence. Are they black boxes and robots? I should trust on them blindly without any further assessment? No, not all artificial intelligence are so. Not all policemen is donut. Not in all detective books, the guilty is the majordomo. No, not all artificial intelligence are black boxes that you have to obey blindly without any further assessment. On the contrary, there are several artificial intelligence techniques that provide you both results and, the most important thing, clear explanations that support those results. And this is the INECO's approach, using artificial intelligence techniques that provide you both results and clear explanations. Other argument that I usually hear is artificial intelligence is going to replace human beings. And again, this is not the INECO's approach. In fact, we are absolutely against this approach. From INECO perspective, the human being should be in the very center of any relevant process in the company. And artificial intelligence has to support human beings. And this is the vision that INECO promotes, using explainable artificial intelligence techniques that support human beings. This quote is the first sentence in Moneyball, a film based on a baseball real story. It's unbelievable how much you don't know about the game you have been playing all your life. This film is about an average baseball team with a new manager that using artificial intelligence achieved 20 consecutive victories by optimizing human performance. This quote suggests that we should do an exercise of humility, because we may think we know almost everything about our expertise domain, and we should accept the idea that we can enrich our methodologies using empirical data. But as we explained before, experts are key. Our methodology contains a list of factors, of predefined factors that impact on human behavior. And this list has been created by experts. And this list is our starting point, but we think that we can enrich the list of parameters by using artificial intelligence. Artificial intelligence can help us discovering some hidden relations between operational and non-operational factors and how well human beings perform their duty. I insist on the idea. Discovering hidden relations, discovering non-expected relations. But not only that, artificial intelligence can show us empirically how big is the importance of each factor on human performance. And in this way, your company can prioritize what to do. Your company can decide just focusing all the efforts in changing 2 organizational aspects, the ones that are more important, and not lose time or money in changing some organizational aspects that don't provide you a sound enhancement. Well, digitalization. Nowadays, big companies are highly digitalized. We shouldn't ignore it. If we lose the opportunity to use all this amount of data to enrich our methodologies, we will be losing an enormous opportunity. If I go from Madrid to Barcelona in my car with my daughter, I have done this trip hundreds of times, and suddenly my daughter interrupts her very important TikTok session to tell me, Daddy, Google Maps is telling us that there is a traffic problem and there are 2 alternatives to solve it. But I have done this trip hundreds of times and I decide ignoring her advice. Well, it's our decision not to use new and external data to make our decisions. But I think that we should accept the idea that we can enrich our methodologies using this data. Ineco has designed and deployed both architecture and infrastructures to process and store all kinds of data, not only figures, text, audio, metadata, video, web page contents. And this has not been an easy task because there were a lot of different sources that were under the responsibility of different departments, and we had to encourage them to lose their sense of possession of the data. So in Ineco, we had adapted our culture to the existence of so huge amount of empirical data. And we can support you in this trip. Ineco can support you in deploying this kind of infrastructures. I want to show you at least a practical case graphically where artificial intelligence can help us to perform a first preliminary prioritization of factors. For the sake of this webinar, we have created a very simplistic and high-level supervised regression model, and we have analyzed just the impact of 5 factors on the number of flights, the number of landings that an air traffic controller can manage. Here you can see the typical correlation matrix that suggests that there are 2 factors that don't contribute as much as others to the performance. We can see that the number of heavy aircrafts, very big aircraft, and the accumulated number of tasks during the first 20 minutes of a peak hour impact severely, or impact not as much as other factors. Again, this information will be given to the experts, and experts will discuss on them, and will decide and will define if there is a way to improve the way of managing heavy aircraft, or if there is a way to support air traffic controllers during the first 20 minutes of a peak hour. This is just an example for the sake of this webinar. Well, just to conclude this panel, let me highlight 3 ideas. First idea, no black boxes. Artificial intelligence has to collaborate with experts to have a better understanding of human performance. Second idea, great companies have to digitalize all their processes, store all their data, and make them available to the rest of the company. And last idea, but not least, great companies cannot miss the opportunity to enrich their safety and human performance methodologies by taking advantage of artificial intelligence and digitalization. Thank you very much for your attention, and I will be pleased to answer any questions you may have.
Thank you, Jose Manuel. I think this is a very challenging scenario that I hope that we know how to take advantage of the information that we can collect. There are some questions for you, but one of them I think is related with the presentation of Marisol. Regarding fatigue and stress, how do you think that can be, what kind of things can be analyzed with artificial intelligence?
Well, fatigue and stress. Well, the first thing we have to think, no matter the domain, fatigue, stress, or the domain, is that we need data. We need to collect a huge amount of data, relevant data. And coming back to fatigue and stress, I remember in the past, we typically collected a lot of data, not a lot, but some data with questionnaires that were filled out by operators after the working shift. Then there were some new techniques supported by some pop-ups on the screen that were clicked on by the operator on the job. But nowadays, I think that we should take advantage of those electronic bracelets that monitor and record blood pressure, heart rate. I think that we can collect all this data, then trace against a lot of external operational data, and let artificial intelligence find some hidden patterns. With this information, we insist, key experts, we have to give this information to the experts. They have to discuss on them and to derive, if any, conclusions and recommendations. This is the approach that I would suggest to address fatigue and stress aspects.
Okay, thank you, Jose Manuel. Now, before going to the final question round, I want to propose another brief survey. Please take your mobile phones again and read the QR that you have seen in your screen. Okay. The question is, I think, is simple in this case. Which application of the human performance methodology do you find most useful in your area of interest? To apply them to an existing system, in the design phase of a new system, to integrate big data or artificial intelligence in the analysis, all of them, none of them. Okay, I think this is not a possibility to answer the survey. So please go ahead while our experts are allocating, getting their place in the scenario to answer your questions. We have information here. Most of you think that the right answer is all of them. Very interesting approach. We have some questions. The second place is to integrate big data and artificial intelligence in our analysis. So I think it's important. Okay. I don't know if we have all our experts are ready to answer your questions. I don't know if they can comment, they want to comment something regarding this survey, but we have, I think they are allocated in the scenario. So just in a few seconds, we will start the final round. I'm reading the question that you have written down on the chat. The first one, I think, is for Marisol. Marisol, we have a question for you. How do you apportion human factor reliability requirements as a part of an overall system reliability budget?
Yes. Well, there are many methods available, safety methods available on the market. Specifically, when we were developing this methodology, we start looking at these methodologies. For instance, all the human reliability assessments are focused on understanding the human error contribution to the overall system. So, for instance, we're starting working with CARA, is a controller actions reliability assessment, RARA in the rail sector. And we learned a lot when focusing on these methodologies, but at a certain stage, we skipped quantifying human error, because at that specific moment, we didn't have all the data we needed to make scientific results in a statistical point of view, significant data, I mean. So we skipped in the very beginning, and we focus our effort on assess the human issues, human factors issues contribution when operators or users are working on a particular tasks. So we can give you more information if you want about these HERT techniques. HERT techniques are the human error assessment and reduction techniques, and CARA and RARA are based on these HERT techniques. These are traditional safety assessment techniques, very useful, but if you want more information, we can provide you with these tools also.
Thank you, Marisol. We have another question, and not close related with the topic, but this is for Victor. Where should be allocated the fees to pay the investment of ISPs, air navigation service provider, and industry for airspace, especially in the ATM UTM interface? Drone operator, airliners, mixed solution?
Well, it's a very good question, although a bit off topic, but well, I can provide my opinion. Well, I think that fees should be paid for those who are going to take advantage of this service. In principle, I think all of them are related. On the one hand, this interface will allow drones entering in controlled space. On the other hand, aircraft and air traffic control will benefit from this investment, as they will be able to react to potential conflicts. So, well, I think that's something that has to be defined at a political level, but I understand that perhaps it has to be a mix of both.
Okay, thank you, Victor. This question goes to Jose Manuel. Along your presentation, you have indicated that there are some artificial intelligence techniques that are black boxes. Which techniques are black boxes? At the same time, could you mention some of them that are not a black box?
Thank you, Daniel. Well, first, to clarify what I meant with black boxes. It's true that we can train very powerful artificial intelligence models that provide you with a marvelous prediction or classification, but once you have these results, you cannot understand how the entry parameters have impacted and have affected to these results. So you cannot learn the relation of these factors on the result. And this is not something that we want. Some examples, is the question, is some examples of these black boxes techniques. For example, if you design a neural network with more than one hidden layer, this is very complex to obtain some information from the model and to learn something from that. Other example, the support vector machine is another technique that is very powerful, but it's very difficult to obtain some information from that. The other part of the question is the contrary, the artificial intelligence techniques that are not black boxes. Perhaps they are less powerful than the previous ones, but I think that the simplistic supervised regression model or the decision tree, they are less powerful perhaps, but you can understand and you can try to learn the patterns of the influence in between factors and the final result. This is what I meant with black boxes or not black boxes.
Thank you, Jose Manuel. I have a question for Tatiana. Could you say something about how do you measure the degree in which each performance shaping factor affects the execution of each task?
Thank you for the question. Yes, in fact, at this stage of the method, we need to have contact with the operator because they are the expert that unless they are going to be in contact with the system. So the first task is to allocate the performance safety factors for each of the tasks. And we can do it by first to have an interview with the expert that operate the system and by obtain workshop. But then we need to have more input to finally decide what is the degree of impact of this performance safety factor. And we can do that taking into account some questionnaires that we can give to the operator that are the final customer of this of the system. So we prepare some questionnaires and give to the operator, and we can do a statistical analysis about with the result of this questionnaire. And with this result, we can obtain the degrees in which each of the performance safety factor can affect on the execution of each of the tasks.
Okay, thank you, Tatiana. I have another question. I think this goes to Marisol. What do you think is the better way to do a human factor assessment? At the same time that you are doing a traditional risk analysis or in any other moment?
Well, I think this methodology is very flexible. You can use it in both ways, but it depends on a little bit on the safety analyst. I think that we can extract the best if we perform it together with safety assessment and with experts and with the end users, because they are who knows what is happening in the real operation. And we can extract a lot of more information from there and creating more synergies between us. For instance, we are creating, for the time being, protocols and procedures to exchange this information. Hazards are provided to safety assessment and human factors studies conclusions are provided to safety assessments also. So it's a kind of cycle, and we can extract the best, of course, if we work together at the same time.
Okay, thank you very much. Probably this goes to Victor. What are the main difficulties that you have found applying this methodology for drones?
Well, indeed, as I told during the presentation, the most difficult condition of US space is that it's a fully automated system which interacts with a system supporting human decision as is ATM. I think this is the challenge in this case, because well, we have to provide or to identify how the human behavior will be improved in a system, interacting with a system which is fully automated. That is a clear challenge, but also it is an opportunity, because it provides also us with the opportunity to understand how air traffic controller could behave in the presence of more automation in the ATM system. So, well, I think this is the most difficult and at the same time the most interesting part of this analysis.
Okay, thank you very much, Victor. Tatiana, please, could you answer another question?
Sure.
Is contact with people who operate the system required during the application of the methodology? How much contact is required?
Yes, in fact, as I was explaining previously, I was talking only about the performance safety factor, but we need this kind of contact with the operator, because for us, these are our experts that in the beginning in the project, they are going to help us to understand the system and how are the difficulties on operate the system that is the daily routine. So for us, it's very important. We can start studying the system with the documentation, with the procedure, or this kind of thing, but it will be very helpful for us to have a first contact with the expert, with the operator, to see in their daily routine with how they operate the system. So this is the first contact. And of course, when we need to analyze the performance safety factor, as I had talking in the beginning, so for us it's very important to have this input about the people who operate the system. Of course, we know that not always is easier to have this kind of contact. So we can adapt. We can adapt for each specific scenario and for each specific case. So the best is to have as much contact as it could be possible.
Okay, thank you very much. Marisol, I think this is an interesting question. Do you think that this methodology is aligned with the safety 2 vision that is considered in the aviation world?
Yes, of course, I think this safety 2 vision is an enhancement of safety methods. I think that during the evolution on safety methods, scientists have arrived to this evolution of methods and technology. And I think that this vision is a good one, because not only focus on the human error, but also normal operation. And there is, as I mentioned during my intervention, that there is a lot of data available from normal operation. And sometimes when engineers design or managers design a concept, this concept is ideal and is not a reality, because when operators need to act or to interact with other people or with the procedures or systems, sometimes they are facing up a lot of problems, but the consequences are null. They don't have any accident, but we can extract a lot of information from there. So safety 2 is very oriented to this approach, to take the most of the normal operation and study, and the human factors analysts need to focus on all the performance shaping factors or conditioning factors that may affect human performance. And this is very interesting since our human factors point of view.
Okay, thank you, Marisol.
You're welcome.
I have a question for José Manuel. Can artificial intelligence be applied in the tactical horizon of the operation to detect hazards or risks, or only in a study at the strategic phase?
Well, I think that we can use it in both stages of the operation. Of course, as I have explained, not to replace human being, but let me put an example how I foresee we can use artificial intelligence techniques in this tactical phase, detecting hazards, as the question is suggesting. With historical data from years, we can detect, or the artificial intelligence model can detect some patterns of different parameters that took some specific values that finally ended in a complex situation. If we train this model and we are able to detect these complex situations in advance, it's very easy just to complement the tactical expert working on the shift with some messages, pop-up alerts, just indicating maybe in the past there were some complex situations when this number of entries happened, when this situation, external situations happened, and then the expert will decide, don't care, I have under everything under control. But I think that yes, artificial intelligence can help you complement your information with some additional information, alerting you that something complex may happen as it happened in the past.
Okay, thank you very much. And now I think we have time for one or two more questions. I think this, I don't know, Marisol, Tatiana, probably Tatiana. Have you defined some rules for the prioritization of the task? You know, location, complexity, whatever?
Yes. In fact, we have defined some rules. We define two factors. The first one is regarding the difficulty of performing the task. And we can do that with the 5 parameters that we have explained in some of the panels. These parameters are not an invention of us because are in the nuclear market, and is the complexity into each of the tasks. If there is a different shift, the location in which the tasks need to be carried out, if you have enough time or not. These are the parameters that is the first step to have a prioritization about the task. So, and this comes, as I have said before, from the nuclear sector. But one of the innovations that we incorporate in this methodology is that we don't have into account only this parameter that is regarding the difficulty of performing the task, but in fact we have into account the hazard regarding that can lead in case that there is a bad execution of each of the tasks. And this is the innovation. I think that this is one of the main innovations that we include in this methodology, and is the point in which we can integrate our methodology with the conventional risk assessment, because we have a hazard analysis regarding each of the tasks, and with the consequence of the severity of the hazard regarding each of these tasks, we can prioritize the task. So we put all together, we put the parameters and the difficulty of performing the task by measuring these 5 parameters, and we take into account the severity of the consequence of the hazard, the corresponding hazard, and by mix all these elements, by application of equation that we have developed, we can obtain this prioritization. So at the end of the methodology, we can have this prioritization taking into account all of these parameters.
Okay, thank you, Tatiana. I think this is the final question. We have some more in our chat. But as I mentioned before, we will answer you via email. But I think this is the key question. Marisol, apart from the example that we have seen in our presentation, your presentation, have you applied this methodology in a real case, in a real scenario?
This is a question that has been asked many times. Well, this methodology is based on valid methods, like all the human reliability assessment methods available on the market. And these methods have been used many times. We have apply the methodology in different scenarios, in different operational concepts, at a different life cycle stages, in different sectors. This human reliability assessment has been applied in nuclear sector, railway, aviation sector. So yes, we have a very solid methodology, and we have learned a lot during this time working with this methodology. We have compiled lessons learned, and we are continuously improving the methodology because when it's not the same when we apply it in railway than with drones, for instance. So we learned that the steps we propose need to be more flexible, and we create more templates to help users to actually use it. And then, thanks to science data, we are improving a lot our methods also. So I think that yes, with this multidisciplinary team, it helps a lot to keep growing. And in fact, I'm glad you asked this question because we are, for instance, applying for a new project, an innovation project, because there is a lot of things to do. We want to develop a catalog of risks related to human factors, and we want to develop another application of this methodology more oriented to change assessment. So yes, there is a lot of work that has done and also to be done. So we are very, very happy with this methodology.
Thank you, Marisol. And now, not just to take more time than it was foreseen, I want to sum up some of the results of this webinar. I think that we are presenting a global, practical methodology that can be applicable to different modes of transport in any phase of the project. Human performance has to be considered not only in the operation, but in the design phase and decision-making processes to incorporate human performance point of view. We need to take advantage of new developments, new facilities, new tools, new thoughts, or to process knowledge and improve safety. Thank you all for your time, for your participation, for your questions. Thank you, Marisol, Tatiana, Victor, Jose Manuel, for these interesting presentations. I hope that the 4 panels that we have presented give you a clear understanding of our perspective and capabilities. If you want to get further information, please visit our website. We give you the link to get information. You have seen it on your screen. Okay. Thank you very much again, and I hope that you, as well as INECO, accept the challenge of including human performance into your organizations. Thank you very much.